Hi all, today we take up a new example number 2 in the topic of how to achieve a desired draft at one end. This is of course in the area of advanced ship stability. So if this is the first video you're watching, please don't do so. Make sure that you watch all the previous videos I have made on topic of ship stability, the links to which are in the description section below, and only then you should be watching this video because this is advanced ship stability. This example has been taken from the book MV Hindship or Motor Vessel Hindship. So make sure that you have access to the MV Hindship hydrostatic particulars. If you don't have access to it, then I can show you in this video how to access it and how to access the values from the hydrostatic particulars and how to use it in the calculation. All right, so let's get started. Today's question says that the motor vessel Hindship is in fresh water and it is at a draft of forward 6.32 meters and aft 7.18 meters. You have to calculate the position with respect to the aft perpendicular from where 140 tons should be discharged to reduce her forward draft only by 32 centimeters. So remember, as soon as you read a question, you should highlight the important points that you would remember or that you would need to remember through the solution of the problem. So the first important point here to note is that you are in fresh water. That would mean that the density of the water in which your ship is currently in is 1 tons per metric cube. That is the freshwater density. Now the hydrostatic particulars, as I'll show you later, are given for a density of seawater, that is 1.025. So that's why you will have to make certain conversions for the density given to you in the question. So this is the first thing you have to note. Of course, you note down the forward and aft drafts. That goes without saying. The other thing you have to notice is the amount of weight you have to discharge, that is 140 tons. The position that you will calculate will be with respect to aft perpendicular, and that is fine. The trick here is if the position is to be calculated with respect to forward perpendicular, that is very important. It is important for you to note down that information because the distance that you will calculate in most of the normal calculations, you actually calculate it with respect to aft perpendicular. So in this case, you are fine with that. You have to reduce only her forward draft, so make sure you remember that information as well. And the amount by which you have to reduce it is 32 centimeters. So after highlighting the important bits and pieces, you start solving the question. So the initial draft is forward is 6.32, aft is 7.18. This is given to you in the question. The difference of the two drafts will give you the trim. So of course the trim cannot be negative, but what we say is if the aft draft is more than the forward draft, the trim is then by stern. So of course you always take the smaller number and subtract it from the larger number. And here the trim, because the aft draft is more, the trim is by stern and it is 0.86 meters. The next thing you have to calculate is calculate the mean draft, and you do that by adding forward and aft drafts together and dividing it by 2, and you get 6.75 meters. Now you have to calculate the mean draft because from the forward and aft draft you cannot decipher the hydrostatic draft. To do so, you need to apply a correction to the aft draft, and you can only do that if you proceed in the way we are proceeding. So using the mean draft of 6.75 meters, you go into the hydrostatic tables for motor vessel Hindship and you find out the LCF value for the hydrostatic draft of for the mean draft of 6.75 meters. So if I go into the hydrostatic tables here, you can see that the draft of 6.75 is not mentioned directly here. What is mentioned is 6.60 and 6.80. So we'll have to do some interpolation. The LCF value is of course here. LCF stands for longitudinal center of flotation. So the LCF value is here. This is the point about which the ship trims. So we have two values and we have to now interpolate between these two values to find out the LCF for the mean draft of 6.75. So from the hydrostatic tables, note down the LCF values for the drafts and then do an interpolation. So how will you do the interpolation? Well, for a difference of draft of 0.2 meters, that is 6.8 minus 6.6, the difference in the LCF values is 0.199. How did I get 0.199? 72.005 minus 71.806. So for a difference in the draft of 0.2 meters, the difference in LCF is 0.199. What will be the difference in the LCF if the difference in the draft is 6.75 minus 6.60, that is 0.15. So for that you will do cross multiplication. This cross multiplication comes here, and then that gives you a correction value of 0.149. This is the correction value. What do you do with the correction value? You always first you have to find out the LCF. So as you can see, as the draft is increasing, the LCF value is decreasing, right? From 6.6 to 6.8, you can see the LCF value is decreasing. So as your draft will increase from 6.6 to 6.75, your LCF value will decrease. So you will take the correction value and subtract it from the LCF value of the draft 6.60 meters. This will be the correction, and you get the LCF value for a mean draft of 6.75 meters. Using this LCF value, you will calculate the correction you have to apply to the aft draft. So how can you find out the correction? Well, the correction is applied by trim multiplied by LCF divided by the LBP. LBP stands for length between perpendicular. And how can you find out that information? You go back to the hydrostatic tables. In the hydrostatic tables, in the first page or so, you have the LBP value given to you. Length between perpendiculars, LBP, is 143.16 meters. So always use the value of the meters, because most of the questions are based in meters. Alright, so you will use this value, go back into the calculation, and you can see the LBP value is mentioned there. So using that formula, trim multiplied by LCF divided by LBP, you find out the correction to the aft draft as 0.431 meters. Use this correction and always subtract it from the aft draft. Since the aft draft is more, this vessel is trimmed by stern. So you will subtract it from the aft draft, and your hydrostatic draft is 6.749 meters. That is your hydrostatic draft. Alright, so using this hydrostatic draft 6.749 meters, you will go back into the hydrostatic tables, and what you will do is you will be finding out three values. You will be finding out displacement. The triangle stands for displacement, then MCTC and LCB values. Alright, you do what you did before. You will go back into the hydrostatic tables, and for 6.6, and because you don't have 6.749 in the tables, so you will be finding out these values for 6.6 and 6.8 like you did previously. So you will find out the displacement value, the MCTC and the LCB. LCB stands for longitudinal center of buoyancy, forward of aft perpendicular. MCTC stands for moment to change trim by 1 centimeter, and displacement is of course the weight of the ship. So you will note down all these values for 6.6 and 6.8, and you will be doing an interpolation like you did before to find out the appropriate values for the draft of 6.749, which is the hydrostatic draft. Alright, so I don't have to show you the interpolation again, because you pretty much know how the interpolation was carried out. So I have done individual interpolation for firstly the displacement. You can see for a difference in the draft of 0.2, the difference in the displacement is 457. So for a difference in the draft of 0.149, what will be the difference in the displacement? So of course this is 6.8 minus 6.6. I'm just writing all this so that you have a quick jog through the memory on how we did it. Right, this is 13840 minus 13383. So you do a cross multiplication, and the cross multiplication will give you the difference in the displacement if the difference in the draft was 0.149. So you will add this displacement to the displacement for 6.60, 13383 plus 340.47, and you will get the displacement. But this displacement that you get is for seawater, because the hydrostatic tables are for the seawater density of 1.025. But remember that your question says your density is 1. You are in freshwater. So to convert this displacement for a freshwater displacement in freshwater for same draft, you will multiply this displacement by 1, which is the freshwater density, and divided by the density of seawater, for which the tables are given 1.025, and you get your displacement in freshwater. Alright, Then we go back and we do an interpolation for MCTC and LCB as well similarly. Alright, so here I will erase all this so that you guys don't get confused. So what you will do is multiply this by this and divide this by this, and this is the equation you get. And similarly for LCB, this is the equation you get. So you have to see here, with increase in draft the MCTC increases. So when you find out the correction value to the MCTC, you will add to the MCTC as I will show you here. Alright, but when you get a correction for the LCB, you have to see that with increase in draft the LCB is decreasing, so you will subtract this correction from the LCB value of 6.60 meters of draft to get the LCB for the draft of 6.749 meters. Alright, but you have to note one more thing here which is very important. Now just like you converted your displacement from seawater to freshwater, you also have to convert your MCTC, because the MCTC you calculate is for seawater. This is seawater MCTC because you got this from the tables. For freshwater MCTC, you have to again do what you did for the displacement. You have to multiply the seawater MCTC by the freshwater density and divide it by the seawater density of 1.025, and you will get your MCTC for freshwater. But for values like LCB, LCG, which are in meters, LCB in meters, whatever you see in the hydrostatic tables, the unit of which is meters, your value will remain the same for seawater as well as for freshwater. You don't have to interpolate it, or you don't have to convert it for a freshwater LCB. So your LCB that you calculated from using the correction value or from the hydrostatic tables will remain the same for seawater and freshwater. You don't have to multiply it by 1 and divide by 1.025. Alright, so once you get the values, using the formula total trim, which is equal to T, which is of course equal to 0.86 based on the initial drafts. Your initial drafts were, you saw above, your initial drafts is 6.32 and 7.18, which gave you a trim of 0.86. So before discharging the cargo, your trim was 0.86, and you know all your values. You know your LCB, MCTC and displacement value. The only thing you don't know is your LCG. So using this formula, you can calculate your initial LCG before discharging took place. Alright, so you've got your total trim. So what you will do is you will take all this here and bring this here. Isolate LCB minus LCG on your left hand side because you don't know LCG, and then multiply the rest and divide the rest, and then you find out LCB minus LCG is equal to 1.133 meters. But LCB value you know is 72.866 from here. Therefore your LCG or initial LCG before discharging operation begins is 71.733 meters. Alright, look carefully at the equation, look carefully at the solution. So this LCB value you will put here and you will get your LCG. Now your initial displacement as you calculated above for freshwater is 13388.8. If you discharge 140 tons given in question, your initial freshwater displacement or your final freshwater displacement is 13248.8 because you will discharge 140 tons. But this is your freshwater displacement. Now you have to go back into the hydrostatic tables, and for that you need the equivalent seawater displacement. To find the equivalent displacement in seawater, you do the opposite of what you did before. Because this displacement is in freshwater, you will take this displacement multiplied by the seawater density and divide by the freshwater density. Opposite of what you did previously when you were converting the seawater displacement to freshwater. Here you are converting the freshwater displacement to seawater, and you get your equivalent final displacement. This is your final displacement in seawater is 13580. So for a displacement of 13580 tons, you go back into the hydrostatic tables. Alright, find out where your 13580 lies. So you can see Your 13580 lies somewhere between here, right? So because it lies somewhere between here, you will again note down the values of the MCTC, LCB, LCF and draft values. Go back. So you note down the same MCTC, LCB and LCF values for that range, and then you do an interpolation. So you don't need this. I will remove the draft, but you have the two displacements, and against that you have the MCTC, LCB and LCF values. So here if you have to do an interpolation, what you have to do is, again, you don't need the draft. You don't need the draft, or you actually need the draft. I have calculated the draft as well, so my apologies for that. So you actually need the draft. Alright, so you need the draft. So what you will do is you will start off by interpolating the draft first. So what you have is, I'll tell you why you need the draft. Sometimes it makes it easier. So what you do is, basically, even if you don't calculate it for the draft, what you can do is start by interpolating it for the MCTC. So let's look at this equation here, all right? So for a difference in the displacement of 457, which is 13840 minus 13383, the difference in the MCTC is 2.1. This is 181.4 minus 179.3. So for a difference in the displacement of 197, which is 13580 minus 13383, what will be the change in the MCTC? So do a cross multiplication here, you will get this equation, and that will give you a correction to MCTC as 0.905. You apply this correction to the MCTC value for 6.6 or 13383 displacement, that is 179.3. you get MCTC 180.205, but this is again for seawater. So what you will do is you will convert this MCTC for fresh water by multiplying it by freshwater density. So put this value here and divide it by seawater density, and you get the seawater MCTC after the discharging is finished. So this is the final MCTC. The initial MCTC you calculated earlier, this is the final MCTC. Similarly, you will do an interpolation for the LCB value. So what you can do is, that's why I said you can either use the draft first and then go as per that, or you can straight away use the displacement. So what you can do is now here. So what you can do is now, for a difference of LCB, you can interpolate the LCB. So you get this equation here. Alright, then you get a correction of 0.013, because your LCB is decreasing with increasing draft, or increasing displacement rather. You will decrease, or you will subtract it from the LCB of 13383 displacement. You will get the LCB value. Now I told you that for values in meters like LCB and LCF, you don't have to do any conversion from freshwater to seawater. This is the final for freshwater as well as for seawater. Alright, so I will also, what I will do is I'll also calculate the draft. Now I know why you need the draft. So what you can also do is calculate the final hydrostatic draft as well after discharging has taken place. So what you can do is, you can see that for a displacement of 457, the difference in the draft was 0.20. So what will it be for 197? And therefore you get this equation here. You get this correction to the draft, and what you can do is you can add this correction to the draft here, because as your displacement will increase, your draft is increasing, and so this is your hydrostatic draft, your final hydrostatic draft. Alright, so your forward draft required is 6 meters, your hydrostatic draft is 6.68 meters, so your forward trim will be 0.686 meters. Now why is your forward draft required 6 meters? Do you know? Okay, let's go back to the question. So you can see here, the forward draft is 6.32 meters, but you want to reduce her forward draft by 32 centimeters. So therefore 6.32 minus 32 centimeters is 6 meters of forward draft. So this should be your forward draft after discharging has taken place. That's why Your ideal forward draft is 6 meters after discharging has taken place, and that's why your forward draft required was 6 meters here. But your hydrostatic draft based on the discharging operation is 6.686 meters, so you need a forward trim by 0.686 meters. Alright, so what you do is you also calculate the LCF by the above interpolation. I will not take you through all that again. LCF is also decreasing with increase in displacement, so you will decrease it or you will subtract it from the LCF for the displacement of 13383 to get the final LCF value. This will be the same for freshwater, seawater, because this is also in meters. Now forward length will be equal to LBP minus LCF. So length between perpendicular, you know it's 143.16 minus LCF that you calculated above will give you a forward length of 71.241 meters. Now why do you need the forward length? Because the forward trim, because you're only changing the forward trim, is equal to the total trim multiplied by forward length divided by total length. Alright, or if you take this here and bring this here, your total trim isolating on one side will be equal to forward trim by total length divided by forward length. So your forward trim has to be 0.686 as you saw above here. Your total length is LBP, which you got from the hydrostatic particulars, and your forward length is 71.241 meters. Your forward length means LBP. So if you imagine this to be your ship, alright, and this is the aft part, this is the forward part. This here between aft and forward perpendiculars is LBP, and this distance here till the center of flotation is LCF. So LBP minus LCF will give you this distance here, which is forward length. This is the forward length. Alright, this is about which you have to reduce the trim. So the total trim that you get is 1.379 meters from this formula. Also total trim is equal to LCB minus LCG divided by MCTC multiplied by 100 multiplied by displacement. Alright, now you don't know your LCG value, so your LCG value will be found out by the formula, because you know your total trim from here, you know your final LCB value, you know your final MCTC value as well as displacement value. So all you have to do is isolate LCB and LCG on one side and decipher the formula like this. Put in the values of the put in the values here of trim, MCTC and displacement. Remember, these are all freshwater displacement and freshwater MCTC and freshwater values. Alright, then you've got LCB minus LCG equals 1.830, but you know your LCB value is 72.876 as you have calculated above. So your LCG value after discharging is 71.046. That is your final LCG. To find out where the weight will be discharged from, you take your original displacement of fresh water, your initial LCG, and that will give you the longitudinal moment if you multiply the initial displacement by LCG. Then you have to discharge 140 tons from a distance unknown, which is x, which will give you 140x. Because you are discharging, you will be subtracting it from the final longitudinal moment or from the longitudinal moment. So after discharging, your displacement is 13248.8, you know that already, and your final longitudinal moment is 96041.418.8 minus 140x. Now your final NCG, which is already calculated above, is also equal to final longitudinal moment divided by final displacement. This is from here, this is from here. Now because you have to find x, you have to isolate x now, so you will multiply, you will take this here, right? When you take this here, this is the equation you get. Isolate x on one side, x is equal to this equation here, and finally x is equal to 136.747 meters. This is the distance from which the weight has to be discharged to reduce the forward draft by 32 centimeters. Alright, so once you discharge it from the forward part of the vessel, as you know that this is the vessel, right, and this is the aft, and this is the forward. Now because you had to reduce the forward trim from 6.32 or forward draft from 6.32 to 6, that means discharging had to take place from the forward part of the vessel. So this is LBP is equal to 143.16. You are discharging cargo from almost 136.747, which is very close to the forward part. Somewhere from here, when you discharge the cargo, the forward part of the vessel will come up and the aft part of the vessel will go down. So as the forward part comes up, the forward draft will reduce, and in this case it will reduce by 32 centimeters. Alright, so let me know if there was any part of the question you didn't understand, and I'll be happy to answer it as soon as I can. Remember, the density is very important in these questions. Remember to convert the right to the right density, because when you are entering the hydrostatic tables, you have to enter with a seawater value. But once you get the value, you have to convert it back into the required density value, which in this case was of course freshwater. Once you again go back to the hydrostatic tables, you again have to convert it to a appropriate seawater value. Bye for now guys, and all the best with your stability exams.